this lesson we're going to learn another method of factoring, and that is to factor by grouping. When you factor by grouping, you will notice that there are four terms. So in this case there are four terms. 4a cubed is one term, 10a squared is one term, 6a is one term, and 15 is one term. So there are four terms. When there are four terms, it does not work to factor it like that. They are not differences of squares either. It's not a quantity squared with a minus sign in between and then another quantity that's been squared. So when you see four terms, you want to most likely factor by grouping. Okay, and what that means is you're going to think of, first of all, factoring out what you can out of just these two terms right here. I'm only looking at what's in green, and I'm going to pull out what I can out of what's in green. So 4 and 10 are both divisible by 2, and then I've got a cubed and a squared, so they both have at least an a squared term. Okay, and then I'm going to figure out 2a squared times what gives me 4a cubed. Well, 2 times 2 is 4. I had a cubed, but I pulled 2 of those a's out, so I have one more a. Okay, and then 2 times what gives me 10a squared? 2 times 5 is 10, and then a squared, I already have the a squared pulled out. Okay, so there's that piece. All right, now I'm going to take, notice I have this plus sign right here, so I'm going to bring that down. And then I'm going to factor out what I can out of just that piece. Okay, so when I factor out what I can out of there, if I look at what goes into both 6 and 15, 3 goes into both of those. So I can factor out a 3. I can't factor out any a's because the 15 doesn't have an a with it. So 3 times 2a makes 6a, and 3 times positive 5 makes positive 15. Okay, now what I want you to notice is if you look at this whole part, all of this, where the black line went across, okay, what I want you to notice is the green and the red have something in common. They both have a 2a plus 5 in parentheses, okay? The green and the red both have a 2a plus 5 in parentheses. Now what you're going to think of doing is pulling out that 2a plus 5 out of both of those, okay? So this green had a 2a plus 5, the red had a 2a plus 5. I am factoring that out. That's what they have in common, so I'm going to factor that out. I pulled that out, and I pulled that out. Now what I want to do is I want to go back in the next parentheses and see what I'm left with. So in the green, I'm left with 2a squared, and in the red, I'm left with positive 3. And that's how this factors. Okay, that's how you factor by grouping. All right, here's another one. Okay, again, I'm going to look at, first of all, my first two terms, and I'm going to look at what they have in common. What can I pull out of these two terms? Well, 3a and 6b are both divisible by 3. One has an a, one has a b, so I can't do anything there. So 3 times what makes 3a? And that would be an a. And 3 times what would give you negative 6b? And that would be negative 2b. Okay. And you're going to bring down this plus sign. And then you're going to look at what do these have in common. So 5 and 10 are both divisible by 5. And each term has at least an a in it. They both don't have a b in them, so you can't do anything with the b's, but each term does at least have an a. Okay, so 5a squared times, or 5a times a gives me 5a squared, and 5a times negative 2b gives me negative 10ab. And again, if you look all the way across, both the green and the red have an a minus 2b in parentheses. So I'm going to pull out that a minus 2b. So I factored it out of the green, and I factored it out of the red. Now I'm going to go back and see what I have left. So I have a 3 in the green plus a 5a in the red. And that's how this one would factor. All right. Next one, okay? So again, same process. I've got 4 terms, so I'm not going to factor it using trinomials. It's not a difference of squares. It's not a quantity squared with a minus sign in between and then another quantity squared. it has 4 terms. So I'm going to group the first 2 and see what I can pull out. So 2 and 6 are both divisible by 2, and each term has at least an x squared in it. Okay? So 2x squared times 1x gives me 2x cubed, and 2x squared times 3 gives me 6x squared. Now, I'm going to bring down the plus sign, and I'm going to look at what can I factor out of here? What can I pull out of x plus 3? And you actually can't pull anything out of x plus 3, so I just have x plus 3. Okay? Now, notice both the green and the red still have an x plus 3 in parentheses, so I'm going to pull out that x plus 3 out of both of those. I'm going to pull it out here, and I'm going to pull it out of the red. Okay, now, super duper duper common mistake. Okay, when I go back and see what I'm left with, when I look at this part right here, if I pull out an x plus 3, I will have 2x squared. That's pretty obvious for people. But when I pull this away, people don't think they have anything left and they want to close the parentheses. However, here's the deal. It's not written, but there is a 1 assumed to be here. 1 times x gives me x. 1 times 3 gives me 3. There's this 1 that's assumed to be here. So you need to have this say plus 1. Okay? Because now if I take x plus 3 times 2x squared, I get the green back again. And if I take x plus 3 times 1, I get the x plus 3 back again. Okay? So it needs to factor like that. Alright. Here's another one. Very similar process. Okay? So I'm going to look at just these two and I'm going to see what I can pull out. So they don't have x's in both terms, they don't have a's in both terms, but there is a y squared in both terms. And so then y squared times x squared gives me x squared y squared. Y squared times a gives me ay squared. Okay? Then I go back here and I see what I'm left with. And I will bring down this plus sign. And I can pull a b out of there. And when I pull a b out of there, I have a plus x squared. Okay, now what I want you to notice is if you look at the green parentheses and the red parentheses, the green one says x squared plus a, and the red one says a plus x squared. And sometimes people think that that's different. But remember that you can add in any order. I can add 2 plus 3 and get 5. I can add 3 plus 2 and get 5. So as long as it's addition in the middle, and you can add in any order, it doesn't matter what order they are in, they mean the same thing. Okay? So, however you want to write it, doesn't really matter. Typically you put it in alphabetical order. So, these two quantities right there are the same thing. You can write it as x squared plus a, you can write it as a plus x squared. You're going to get the same answer because you can add in either order. I'm going to call it a plus x squared just because then it's alphabetical. And it's kind of mathematically polite to do that. Then when you go back and see what you're left with, out of the green, after you've pulled out the x squared plus a, you will have y squared. And out of the red, after you pull out the x squared plus a, you have that b left that's out in front. So this is how that one factors. And this is our last one here. Okay? Again, if we look at the green, and I want to figure out what I can pull out. 44 and 8 are both divisible by 4. Each term does at least have a p to it, and that's all you can pull out. So here we go. 44 times 11pq makes 44p squared q. And then 4p times negative 2 makes negative 8p. Okay, bring down the plus sign. And I'm going to look at what I can pull out of this quantity right here. So, 66 and 12 are both divisible by 6. And then 6 times 11p makes 66p minus 6 times 2q gives me negative 12q. out, when you look at the green and the red, you'll notice that they don't have the same thing in both parentheses. This and this are not the same because this is missing that Q right there, okay? And I can't just add it, can't just put it in there. And so this one is actually not factorable by grouping.